Hi, very good morning. Jim from Avstar. I've got that good at looking at jet streams and their patterns. I can tell exactly what month or around about what month of the year it is just by looking at the jet streams. Can you believe? I'll give you, for instance, this could be around October, October-ish, because they're evenly positioned. I know that they're more heavily on the southern hemisphere. They're not equally positioned, so I know it's not slap bang in October or around about that month. I know it's not November, December, January, February, because if it was, there'd be more jet streams over the northern hemisphere, and around June, there's more jet streams around the southern hemisphere, so you can tell the dates by just the positions of the magnetic north poles. So that's top left. If we look over on the top right, you can see a chart breaking down the polar jet streams and the subtropical jet streams, and then you've got the polar cell, Ferrel cell and the Halley cell, which meets the other Halley cell on the other end of the equator. And you can see 30 degrees subtropical, 60 degrees polar jet streams. Now this was the standard model 25 years ago. It's no longer the case. So we have, as I've shown and reported over the last few years, interchange over the equatorial region between the Halley cells of the northern hemisphere and the southern hemisphere. And I've also reported on the fact that the polar jet stream in 60 degrees north and 30 degrees north are now interchanging with each other, and you only have to be a kinder school participant to understand what happens when things that are warm, holding a lot of moisture, suddenly reach their what's the word I'm looking for? So when you're talking about this and you don't script it, this is what happens. So yeah, it reaches 100% humidity, and of course that causes a dropout of the water that's held in the cloud in precipitation or water vapor or rain, basically. And that's one of the problems we're having. That's why we're seeing 30-year, 100-year, 150-year, 200-year, and even 500-year records being broken with flash floods, droughts around the world. It all depends on the positioning of the jet stream. So if it's carrying a lot of humid, moist air from the subtropics, as soon as it hits the colder regions, it could break down as snow over the northern hemisphere. If it's happening in the subtropics, then it's a lot of rain that's going to come down, and that's why we're seeing these dramatic changes. On the bottom just shows you a few molecules. So to start with, we've got carbon monoxide, and then we've got carbon dioxide and water, H2O, and then we've got methane, CH4. You can see why CO2 and H2O are considered greenhouse gases, because they both consist of a tri-molecule or three molecules. CO2, one carbon has a valency of 4, so it can bond with 2 oxygen atoms, which each have a valency of 2, so it connects perfectly with the negative and positive charges. We won't go into that. And likewise with the H2O, oxygen having a valency of 2, hydrogen a valency of 1. The electric combination of those molecules is perfectly balanced, and therefore they become strongly binded. But however, they can be broken. And water, simple experiment you can do with a 9-volt battery, little bit of sodium chloride or salt in the water, and then 2 probes in there, and off each probe that conducts electricity that goes into the water from the 9-volt battery, you'll be able to produce oxygen atoms on the one probe and hydrogen atoms on the other. So they can be broken down, and we can break down other structures like hydrocarbons via the use of catalysts. So you know, we've found in chemistry lots of ways to manipulate these things, but more in general, carbon dioxide and water vibrate when they come into contact with things like photons. And we know what happens when molecules start to vibrate. And that's one of the reasons why they're considered greenhouse gases, because of their ability to vibrate when they intercept energy, even low EV electricity or electron volt electricity on the minute scales. They still respond to it. And just to give you an idea of that, well, just think about what happens in your microwave and how that heats up the food. It's basically rubbing or jostling or vibrating those little particles that make up that food that's in your microwave. And of course, when things vibrate, they get very hot. And same is for this, only on a smaller scale, on a bigger scale as well, in terms of the quantities of these things, but on the atomic scale, these things are happening. Now, you know, I think if we want to understand what's going on with our weather and our climate and the risks that we face now, I just want to, you know, put aside one common thought thing. And I don't know whether it's been deliberately put out there for people to accept, but it is a misconception. If you think that when the magnetic poles on our Earth change, the only noticeable difference will be the compass will no longer point in the north like it used to, it will point in the south. That is incorrect, because we know when the when the magnetosphere weakens through whatever is causing that, still quite widely unknown how the magnetosphere is generated. We've tried to recreate it many times in laboratories. Some of the elaborate experiments have ranged from heating molten sodium and then trying to rotate it in order to get an electrical current present which would produce a magnetic field or a magnetosphere, and not been very successful. So we really don't know what the causes of the creation of the magnetosphere and and in turn the dipoles on our planet, the magnetic poles. But we know that these things happen. And if we look at the historical record going back millions of years, we know that the Earth has gone through multiple magnetic reversals. So on the long scale of things, it's pretty normal. Only recently, you know, my attention's been drawn to specific facts, say recently, over the last decade now, or within the decade. And that is the amount of time overdue, the reversal, which is 500,000 years. You know, on average, it used to go for a reversal every 350,000 years. And then we're going through a long period of time where it hasn't gone through a reversal. You know, questions arise from that. Something slowing down in our core? Is the core solidifying like it possibly did on Mars? And the reason why I say that is because, you know, Mars hasn't had any volcanic activity for millions of years. We know that it used to. All the terraform evidence is there. We know it used to have water. The terraform evidence is there. You know, those little veins that you see running over Mars are erosion marks through rivers that used to run on there. And now there is no visible signs of these rivers. What happened to the water on Mars? And more importantly, what happened to the magnetosphere on Mars? And again, we knew it had a magnetosphere. And that was due to a recent spacecraft within the last few decades flying over the surface of Mars. Had a very precision magnetometer instrument attached to it, and as it flew over a recent impact crater, it detected a slight magnetic current over that crater. So indicating that, you know, at some point Mars had, you know, something that generated a magnetosphere that obviously left the charged magnetic terraform in a certain magnetic environment that still exists today. Only it was a nice opportunity for NASA, I suppose, that was running the space mission. Can't remember the spacecraft that flew over there, but it was a good opportunity for them to explore the disturbed surface through that impact crater and therefore detect what was going on. And of course now we bring that information back here at home and start analysing all these things. And me, I just put, I'm good at, comparisons. So, I looked at the fact that Mars had, dipoles at some point, magnetic field, maybe, and most possibly, yeah, of course I'm going to say it, it had a magnetosphere, because it must have, to protect its water on its surface, and it must have had, a reasonable atmosphere as well. And these things are not present there anymore. And I just wonder, with this 500,000 year delay that we've had during the last magnetic 500,000 years of delay in the magnetic poles reversing. I just wonder if this is a sign of something slowing down, and could it possibly be the beginnings of what happened to our neighbouring planet? Because let's face it, we know it is possible. It happened to Mars, and whatever was the reason it happened to Mars, if we understand that it could possibly happen to Earth, then we know it's a possibility. How likely is it to happen? But this is what we're trying to understand. There's not a lot of information out there on this, and the reason why some people say to me, "Are you recording, the pole migration at a resolution of every 3 seconds?" It's a bit like watching paint dry, isn't it, Gene? I said, I'll just say this: well, we don't know when exactly it's going to go for its reversal, but at that point in time, if I was to check on it every 2 days, we might have missed a majority of what took place within those 2 days, which could have been very valuable data to the scientific community. So that's why it's done on a 3 second interval, even though we're collecting more information than what we need at this point in time. The uncertainty of when it happens, we don't want to be caught in the middle of the night with no oil in the lamp, if you get what I'm saying. We want to be primed and ready all the time, so that if we ever experience a rapid pole shift over a period of 2 days, I'm not saying that it can happen over a 2 day period, but we've got it covered. That's the main thing. So I think if we want to understand what's going on with the magnetic poles today, and we want to understand what's going on with our climate today, then we need to go over some of the basic stuff. And I know I take for granted sometimes that people have been following me for years, and I know a lot of the stuff that I've talked about. Obviously, some of the newer people that subscribe to the channel haven't heard about it, and I know that they're going to want to. So sometimes, and I apologise, sometimes we're going to go over some of the older stuff, so that everybody has a reasonable foundation into the study of geomagnetics, and also climate, and some of the other related anomalies that are taking place on our planet. I'm not going to go too much into the blatant lies that are related to man-made carbon, and because we've talked on these subjects, you're going to guarantee a banner being put up by YouTube trying to brainwash people, overriding everything I say, and then blatantly in front of your eyes putting this man-made carbon nonsense and lies in front of your eyes. And it really is down to you who you want to listen to. You want to listen to YouTube, or you want to listen to someone who's honest, who's studied science, who wants to educate people, wants to inform them of what's going on, what's important, being as they are a participant on this earth. They live on this earth, and therefore should be fully made aware of what's happening, because let's say everything goes terribly wrong in the future. I just want to bring your attention to how difficult it is to survive in an environment such as outer space, and just point your thoughts in the direction of the International Space Station and what they have to do in order to live, or basically, I won't say live comfortably, I'm going to say survive. Now, we take it for granted because we've got a magnetosphere, we've got an atmosphere, we've got plenty of water on our surface, all of the things that support a planet with life on. So if we lose these things, you know, you can use your imagination. You know, we're not here to frighten people, and we're not saying that this is going to be the outcome, because our Earth, whilst it's had water on its surface, has many times gone through you know, this process of magnetic reversals. What I am saying is, for some reasons, this reversal's not the same as others. And that was the phone. Just bear with me. Trey, can I give you a call back?
Okay.
Okay. Sorry about the interruption. But where was we? So we need to not take for granted that this delay doesn't mean that there is something else happening. You know, if we take that off the table, then we might be missing something really big here. You know, the fact that we've spotted it could be very important. You know, I'm hoping that this reversal at some point does take place. I hope that the magnetosphere doesn't collapse completely, and if it does, that it is for only a short period of time. But look, for 125 years to this day, we've been going through the reversal. So I would presume that before it goes to its completed reversal, even if the magnetic poles flip today, it'd be 125 years for the climate to settle back down into a prolonged period of rhythm, which would be classed as a relative norm. So we're not even at halfway point yet through this reversal. And then there's the reason as to what we have to ask is, why did it take so long this time for it to go for a reversal? Why is it overdue by 500,000 years? And is that going to be something that causes the magnetosphere to collapse and have a prolonged collapse period? Because I'll just say this, it isn't just your compasses that are going to flick from north to south. There will be a lot of inbound radiation which will reach the Earth's surface. There'll be a lot of sputtering taking place from the erosion of the photons that come off the sun, collide with the upper atmosphere, knocking those particles out into space, which will never be recovered ever. You know, once they're gone, they're gone. We knew that sputtering takes place because NASA have studied this on certain missions, and that's where the term sputtering come from. It's the erosion of a planet's upper atmosphere, and maybe the reason why they studied that is to bring it back to Earth and say, look, is this what we're looking at in the future of the further weakening magnetosphere? And if so, then how much are we are we standing to lose of our upper atmosphere during this change? So the delay of the 500,000 years is very important, because now it looks like if it's a very slow process of magnetic reversal, then it could be a very slow process at the equilibrium point, the balancing point of where the poles reverse. How long at that point do they stay, keeping the magnetosphere down? And that's the critical point of survival for us human beings, not just for human beings, for every species across the entire range on this planet. That covers vegetation and biological, human or animal. So, you know, it's not a clear-cut science. There's a hell of a lot to learn. We do know the history, we know the time periods relatively. There is still a lot of data because it was never collected during the last magnetic pole reversal 780,000 years ago. Even if we're looking at excursions, it was never collected 12,000 years ago. So excursions have failed reversal, as you know. The magnetic reversals are permanently reversed for a prolonged period of time. So we don't know. There's a lot of them, a lot of missing pieces of the puzzle, and that is where we are. We're trying to understand everything, and this is why it's such an important topic. You could forget CO2, man-made climate change, like you're going to see in that banner down there, which is a load of drivel. It's driven by criminals in the pretext to just steal taxpayers' money. And this is why we're seeing, and this is why sometimes we do touch on political subjects, because The science is being withheld through political reasons and corrupt reasons. And that's why we touch on these things. If you have a look what's going on in Italy right now and other countries in Europe, you'll see there's a lot of public unrest. Yeah. And they're sick and tired of people like Donald Trump coming and demanding that we spend 5% of our GDP on nothing but bombs and weapons that we usually and generally give away to other countries to fight their conflicts, which inevitably end up killing people. And I don't think any of the taxpayers in Europe, or even in America, Canada, Australia, New Zealand, you name it, Africa, want to pay for people to die. They don't. It's only the rich elites that have a corporate interest in that. And that's why we get into the political arenas on some subjects. And I understand you don't want to hear about that. You want to hear about the pole shift news, the progression of it. You know, you can't talk about it without talking about some of these political issues. It's just impossible, because what's going on right now is the biggest public deception internationally, and I've never seen anything like it. You know, the level of which, I'm going to say again, Donald Trump, not picking on Americans there, but Donald Trump is trying to acquire TikTok because it can't control the democracy on that TikTok has. You know, it doesn't restrict people for the same reasons as YouTube does, which is owned by America. You know, that's why Donald Trump wants to capture it, because in essence, you know, it is still a relatively good platform, allowing people to speak on whatever topics it wants. It does have rules. Well, I haven't got a problem with certain rules. But, you know, when you don't allow the freedom of speech on general topics such as this that we're talking about, and other climate related topics, and other pharmaceutical topics, and you know what I'm talking about there, don't you? You know, then it shouldn't allow it. You know, I hope TikTok never sell to America, ever, 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 because if they do, they hold the conglomerate, they hold all the strings then for media, along with that effer. You know what I'm on about, don't you? The one who owns all the media, Rupert Murdoch. You know, how these people are still participating in our world is way beyond me. I really don't. But I think, you know, that in general, people are getting fed up and tired of it. And, you know, they're being pushed to the point of bravery, where they come out and do something. And if we do that on a collective scale, we can change all this corruption overnight. You know, it's just, I could go on and on and on, but I don't want to, you know, prolong the video and make it way too long that nobody holds interest. I'm going to, in fact, leave it at this, and we can pick up on some of these other topics related to what's going on our planet tomorrow. But I will not leave it at one point. You know, we all like free things. And don't press the button there, don't be ignorant and just go. Because yes, you've probably been smart enough to work out what I'm going to talk about next. If you do that, you show exactly what sort of person you are. And I'm just going to say right now, before you leave, you're no longer welcome in this community. Okay, if you're one of these people that can't listen to me trying to raise some money for this topic, then, you know, if I don't catch you in the comments section and block you, then I expect you to leave and don't ever come back. I really do. Because this is a community that supports the study of this topic. And, you know, because we do, other than talk about these things, we actually build, you know, equipment and try and get it in other countries around the world, you know, so that we can collect what's going on in their environments as well as ours. You know, then you obviously have costs involved. Now, just because, you know, I've recently got myself in a very, very good job, and it's very well paid, and there's lots of other benefits associated with that, you know, it doesn't mean that I should put the bill every month for all this, because it ain't going to happen. So if you're serious about this and you want to stay informed about it, then you have to support. It's not no longer voluntarily, you have to. Otherwise you are a tourist on the subject and you don't take it seriously. And if you think you can keep coming here for free information, then you're wrong. You're as wrong as you can go to your shop and, you know, just take whatever goods out the shop you want and not pay. You're as wrong as that, you know, because that shopkeeper has to buy that in order to make a little bit of profit on it. You know, I have to buy equipment in order to talk about this subject in a little bit more depth than all the other people that just regurgitate all what they find on the internet. So don't be offended by me saying you have to support. You know, if you are offended, then perhaps you should consider, you know, going, because it's not about numbers for me. You know, I've never asked, if you believe it or not, I've never asked people to subscribe to the channel, because I like to think if people want to, they will anyhow. You know, a lot of channels have built themselves up through begging people to subscribe, begging them to put things in the comments. It does help the algorithms, that sort of thing. But, you know, I'll do it in a more honest approach. You know, I assume that people know the score. You know, that if you want to invest in this study of this anomaly, then you can't just go around bobbing on websites taking information, because you don't know how genuine that information is. If you've got your own equipment, you know exactly how accurate the information you're giving out is. And we've got a lot of equipment here at the observatory, but it does require, you know, a bit of funding. So on that note, guys, we'll be back tomorrow. We'll stay on topic. Yeah, you know, like I said, sometimes we do deviate, but that can't be on. And there's links down there in the comments section, sorry, in the description, if you want to help and support the community. And if you don't, then I've already told you what you should do. And on that note, I'll say what I usually do. You take care of your loved ones, as always. Bye for now.